Hello, everybody. Good afternoon or good morning. This is Jose Fuentes from the Reuse Company, and welcome to this webinar. This is the last webinar in this year. This webinar is on requirements-based systems engineering. So let me introduce you to the presenter of today's webinar, and the presenter will be Dr. Juan Lorenz. He's the CTO of the Reuse Company, member of the Spanish chapter of INCUSE, co-chair of the Ontology Working Group in INCUSE, member of the INCUSE Requirements Engineering Working Group, contributor to the INCUSE Guide for Writing Requirements, and a certified systems engineering professional by INCUSE. So please, Juan, go ahead.
Yeah, thanks everybody. Can you hear me well, Jose? Is the sound proper?
Yep.
Okay, very good. Nice to meet you all. Today we are changing a little bit topic, as you probably are aware of. You are following our webinars. We are talking about new stuff, new technology that we are delivering now beginning on 2018, and particularly the effort that we have done around requirement integration into model-based systems engineering. So you get in front of you the content. I hope that I managed to talk for only 35, 40 minutes, and then 10, 15 minutes of demos, and of course there will be then some questions, I hope. So very briefly about TRC. We are getting bigger and bigger. As you can see, we have now a very nice set of people working around the whole world and trying to sell and explain the technology that we are offering to the market. We still are very strong in aerospace and defense, but growing in different other sectors around the big four, safety-oriented. And we are now offering the version 18th of our tools, which for you that know the previous versions, we have included the System Interoperability Manager, which is a little bit the topic of today, not a tool, but capabilities that we can offer within it, and improvements in the RAT, the Rich Authoring Tool, formerly Requirements Authoring Tool. So, wishes upon a star. So I wanted to explain a little bit what kind of things could be interesting in our perception around merging, putting together requirements with models. And I thought that the best way to start was to talk about interesting possibilities, or perhaps present possibilities. But for us, we think that there's quite a lot of things to offer in the future for you guys that are users around bringing requirements into models. And the first use case could be to perform requirements engineering in the way we usually do, but as a part of model-based systems engineering processes. So I'm sure that you need to develop requirements, but I'm sure you know that many cases they are affected by existing models, even architectural models or other kind of patterns models existing and so on. And in many cases, you know that requirements evolution and management will also affect those models, eventually changing them. So we would like to perform modern requirements engineering within models development. So we would like to handle requirements, but perhaps in combination or together with models. And on the other side, there's many people trying to kill requirements as statements in text. And in most of the cases, this is probably not possible because requirements are not only necessary to be verified, but also to communicate things. So in most cases, we have to have these requirements. So we would like perhaps to have these requirements as statements also inside models. So what about wishing to automatically trace requirements and models when they really depend on each other? The second use case that I think it could be interesting was, and I think there's happening quite a lot now about it in the market, is the possibility to simulate requirements together with models during the requirements authoring process. So when we are writing requirements, I think that we would really like to have options of checking if those requirements are just breaking some laws, either physical or architectural, logical, or whatever, just by running requirements from the requirements management system within the help of FMUs, models, and so on. Indeed, it would be great, I think, if by running these requirements against the physical models, we would get on the fly the information of if the requirement is valid or is not valid exactly, for example, inside integrity in PTC or doors or whatever, just exactly when we are writing them. Another use case that I think it could be very interesting is if we have struggled to produce a good requirement specification, why shouldn't we try just to generate the models out of the requirements? At least the first draft, that we can then, of course, work on that. The notion of avoiding the blank paper. Why shouldn't I think of the other way around? If I have models, if I like to work with models, could I generate requirements out of those models? And of course, could it be possible if I do these kind of things to trace them automatically, to have all this traceability already, this boring traceability work already done in advance and automatically? And supposing that everything goes well, what happens if I change the requirements or if I change the models? Could it be possible to manage all this traceability as well? What about working a little bit outside the logical or physical models, but getting into other possible automation around requirements? We need, in most of the cases, to generate test cases out of the requirements. In theory, we should have to do it when we write the requirements. Again, if we are writing requirements, why shouldn't we try to get all those test cases generated somehow automatically when we are writing those requirements? Or perhaps the scripts around Simulink, or why shouldn't we translate these test cases into other languages on the fly as well to develop or to implement those test cases outside my country? Or should I also generate requirements out of requirements? If I have information about how my detailed design is really going to be, why shouldn't I try to generate automatically those requirements based on the system requirements, for example? So this is a little bit the wishes that I think that could be nice, or they are nice to be tackled by us, a kind of problem solvers at tools level, that is Reuse Company. So let's get very quickly, you know, we have only 30 minutes for all these things, so let's get very quickly on our notion of model-based requirements engineering. Okay, so to start with, I would like just simply to start from the notion of model-based systems engineering given by INCOSE. Well, everybody knows what it is. Formalized application for modeling to support systems requirements, design analysis, and so on. Models are part of the flow information among activities and process, eases traceability possibilities, and enable computers to operate. So the model-based systems engineering approach, you know much better than me, just come to fight a little bit the chaotic document-centric approach that is very good, but is very bureaucratic. So we work quite well with it, but it is quite heavy to do that. So the notion is, instead of just having standalone models related through documents, model-based systems engineering intends to define a shared system model with multiple views, and then this is a kind of way of tracing everything against the common knowledge point of view. This is the way I would like to see model-based systems engineering. So this model-based approach, and I also want to tell it to you, it's in my point of view, affects everything. It doesn't only affect architectural design and detailed design. It should affect everything. It should affect the processes of our system analysis. Of course, should affect stakeholder requirements. It should affect requirements analysis, and it should affect all of the different processes that, according to the 15288, should we have to perform when we develop property systems. So, so this notion of bringing requirements into model-based systems engineering is very interesting for us because we have been, since the beginning, I think, known in the market as a requirements quality management company. So we manage requirements, and of course, we think that requirements inside models could be very interesting for us, of course, and for you. Most of the cases, really safety critical companies need to certify their systems, and in those cases, the system certification processes force to work in a particular way with requirements, and that would be very interesting if we can start thinking on bringing these requirements as well into model-based through connecting requirements engineering to traceability for the whole system, system analysis through simulation, and of course system verification and validation, because it's part of the must of the V model. Okay, very more specific slides around what is it, or what do we want to mean with model-based requirements engineering. So of course, the concept, it's starting to be well known in advanced systems engineering, is somehow the way to perform requirement engineering based on models. We have the notion of not forgetting the creativity that imply to write natural language. So we don't want to draw models as part of the requirements engineering. We think that requirements engineering still has to have the creativity process of humans defining their needs in their own language. And our approach for model-based requirements engineering is to bring natural language text automatically or semi-automatically into the model-based approach by giving whatever kind of transformations necessary for tracing, creating, or eliciting information with models around the requirements text. So the kernel concepts for us around model-based requirements engineering is, if we want to bring requirements with the rest of the work products, we have to have universal access to everything. So model-based requirements engineering must be based on the notion that we could be able to connect requirements with whatever is necessary, and usually it is everything. So this slide is well common in us that collaborate in several research projects around the world, and it comes from Ericsson. This is quite old now. It's perhaps 8-10 years old, and it by that time it was Mats Berglund was clearly describing that the tools ecosystem around organizations with a level of complexity big is usually quite large. So the challenges for model-based requirements engineering in our approach should be the need of intra and interoperability between and along all those different tools. The notion of the reason why we are saying that is because if we want, for example, to offer generation of models from requirements, well, it's completely necessary to connect requirements with models. Or if we want to have generation of test cases, or the other way around, of course, we have to connect these different tools. So interoperability is a must from our point of view. How do we approach this interoperability or this universal access is through, of course, several interesting activities and means of standardization around interoperability, particularly the OSLC, Open Services for Lifecycle Collaboration, initiated by IBM and now a little bit on the hands of Oasis. We are promoting an OSLC knowledge management, where a single connector would be able to interoperate between all of the different tools. So you can see there are quite a lot of possible tools. The notion would be that Rhapsody could collaborate with Rekif with no need of mapping particular specific OSLC requirements against whatever future OSLC models would happen, or Simulinks or whatever. So it's only one OSLC connector to everything. The second principle that we consider necessary to have a proper model world around requirements is the notion of shared knowledge. I want to sit down on the definition of model-based systems engineering and a single system model shared. So I think that it is completely necessary that we have the choice in model-based requirements engineering to define the notion of system repository, where everything is being stored or linked. Some of the different information and knowledge elements are inside the repository, and others are simply linked from outside. But this notion is necessary. We call it knowledge base. The third, shall we say, common element is the need of representing everything in the same way. So for us in Reuse Company, with that name, you can imagine that our goal is to offer you reuse technology for managing and improving your systems engineering by traceability, transformations, quality, and retrieval. So this notion is critical, and this we've been working with it for many, many years now. So the possibility to represent, as you can see here on the left side, requirements in the same way that can be represented physical models in the right side or logical models in the same way, allow us to work very, very well when the transformations are necessary in order to get or bring closer requirements with the rest of the models. So all these kernel elements for us represent what we call knowledge-centric systems engineering. This is what we like to sell in our approach to the market. We consider interesting to think on systems engineering on the concept of always storing knowledge that would allow us to be smarter when we produce our systems. The system knowledge repository, including the system knowledge base, as I told you, and the system asset store that stores the formal and unique representation of all the different work products. Okay. Even more specific notions about model-based requirements engineering is the way we formalize requirements to produce this formalization that would allow us to do everything. So for us, we consider the input, the natural language text, as you can see. If you are a former customer, you know that we work with ontologies, and those ontologies include many things, but one of them are the requirement patterns. So we can produce graphs, conceptual graphs out of requirements text or risks text or document or whatever by just applying requirements patterns, which are kind of statement level templates for text. You can see, for example, in this example that we have a text, a requirement, and then we have this layer in the middle with colors that represent the structural organization of a requirement to if it must be mapping this pattern. So if I want a requirement to map this pattern, this particular one, we have to have a D at the beginning, then we have to have a term of a particular semantic type, in that case, aircraft, shall, and then we have to have a verb of a particular semantic type, in that case, operation, and so on. I'm going to show you an example of an ontology now in the next slide. And the result of this pattern mapping would be that we can generate some conceptual graphs out of the requirements, and then with that graphs, we can do quite a lot of things. Okay, let me show you a more close example. The ontology for Reuse Company technology and then customers is formed by several layers. The first layer, as you can see, is the terminology layer with all these possible and relevant terms. Could also be verbs and could also be measurement units and numbers, whatever necessary to formalize the requirements in an automatic way. Then we have relationship between terms, and this is the thesaurus layer. You can see, for example, as we were saying in the example before, that we have the aircraft cluster of semantic cluster describing those terms that for the system are aircrafts. In that case, it's the A380 and A350. Then you can have a hierarchical relationship between the terms. Environment is a temperature or pressure for this particular domain, and so on. Then you get the pattern at that level, and then you can have some generation rules where we generate these conceptual graphs. So what is meaning here, the generation rules, is that the graph would be formed by connecting together the term that map the aircraft class with the term that map the environment class, together with the number in the example and the measurement unit. In green, you get syntactic information. In gray, you get semantic information. And in yellow, you get terms, simply terms. For example, let's put an inference rule inside our ontology describing that if a number is lower than minus 60 degrees Celsius, or the number is greater than plus 60 degrees Celsius, being that number the number that we have in this pattern, then the text that is mapping that requirement is wrong. So that means that if I have a requirement describing that the aircraft shall operate at a minimum temperature of minus 70 degrees, we can now clearly say that it is not matching the inference rules, so this requirement is wrong. Okay. Very quickly, we like to formalize everything in the same way. So the requirements here on the left side will be formalized in that way, but models would also be formalized in the same way. For example, this sequence diagram, it must be also formalized exactly in the same way. Indeed, these two, for a reuse component technology, these two work products are describing the same thing. The requirement in the left side, the model in the right side. Okay, so how do we do the second approach of all these use cases that I told you in the beginning? How do we generate requirements? How can we create requirements out of models? How can we generate test cases out of requirements? The technology behind is just simply mapping patterns. So we do the patterns links at the ontology level. And that means, for example, that if we receive a text, we are able to define what kind of text would be produced out of this input. So when you see here, when the fan is on, the green LED shall turn on. This is, of course, should be a requirement, and this pattern one must be a pattern for mapping requirements. And then this pattern, it would be linked with patterns that generate test cases, for example. Pattern 2, it is a pattern that generates a test case. For example, turn the fan on, ensure that the green LED is on. And you can define the information in the way you would like. And what is necessary then is just to map in a smart way. And I don't have much time to tell you, but you can imagine that you have to map in a very smart way the terms in the input with the terms in the output. So if you consider that some requirement is critical, then you can produce some information in the ontology describing that, for example, the interval to be testing that one would be 1 degree. So then the test automatically will be created, creating tests for 1 degree below, 1 degree over the temperature in the requirement. So this information can be gathered and stopped and managed in the ontology. You can see pattern 4, that is a pattern for producing other language test cases. Okay, so bring requirements to model-based systems engineering in concrete aspects. We can think of the possibility to create requirements out of requirements. It's rex to rex, or create low-level requirements out of requirements, or generate models out of requirements, or generate requirements out of model, simulate requirements, generate test cases, anonymize requirements. I mean, in principle, there's no limitation. The only thing you have to do is define your own needs. So let me see. We are more or less on time. So let's go and see some demos. The first demo I would like to show you is how do we offer possibilities for requirements interested people, requirement analysts, business analysts, or people that are interested in studying the possibility to produce requirements engineering, but inside modeling tools. So the scenario I'm going to show you is the RAT, our rich authoring tool, running inside Rhapsody. So to simplify a little bit, we are putting an authoring tool for managing requirements, an authoring tool for authoring requirements, it's twice the same word, inside Rhapsody. So I'm sure you remember and you know that Reuse Company does not have a requirements management tool. We simply rely on you guys that are in the tool vendor side or other tools that produce management for requirements. The only thing we do is we do authoring of requirements. So the first thing that we are going to see is how can, for example, create or edit requirements, real requirements, textual requirements inside Rhapsody. Okay. So you get Rhapsody here. And we are going to get into a particular, it's a bicycle diagram, electrical bicycle, I think, is the model. And then the only approach that we are going to see in this video is how can you create requirements with the power of the former RAT. You get it there. And this RAT is the text editor that we have inside Doors and all the other requirements management tools for writing requirements based on patterns. The good point in this approach is that now RAT is working together with Rhapsody. So that means that this battery that you're seeing here is the battery class that exists, or the block or whatever it is that exists inside Rhapsody. So when you write this requirement there, the RAT is going to link, of course, the requirement with the battery. And then let me stop here because we would not show you anything, but if you want to create a dependency link between the originator of the requirement and the requirement, it is also possible. So what this meaning is that we are trying also to automate the possibility to trace the requirement with the different model elements. So once the requirement has been authored inside Rhapsody, inside the RAT, it is just been sent back to Rhapsody. The second demo I'm going to show you is the same one, so it's nothing different than the need now of creating requirements based on a particular pattern. So you see here, for example, in Rhapsody that we have this state diagram, and now we are going to write a requirement. In that case, we will edit this requirement directly in Rhapsody, but then, sorry, we will create it from Rhapsody, but then we will edit it from RAT. And the point here is that we are going to ask the author to follow a particular pattern, those patterns that I told you in this 25 minutes of presentation. So now you have this, let me stop here a second. You have these two red frames that you have seen, you see here. For those of you who are customers, you know that these frames describe the quality of the requirement. And of course, this quality information, you have it, of course, available for you inside Rhapsody. So it's telling you now that this requirement is awful because it's, according to the correctness metric summary, it is very bad requirement, and it is not this right side, this right pane, and in the left part, in the left frame, it is telling you that it's not following you any particular requirement pattern of the organization. So now what we are going to do is select a particular pattern. This is not new for you guys, all customers. And then the only thing we have to do is we have to write the pattern. But now the good news is that this pattern is also connected with Rhapsody. So when it demands a particular system element, the possible available system elements are only from Rhapsody. You can see here that these states are only the available states inside Rhapsody, and there's nothing else that you can do than just following the possibilities that exist in the model that you have done. So this requirement, if it becomes green, and I'm sure it will be in a second, there is green now. So when you send it back, that you know that this requirement is written according to the organization of requirements typology that you have inside. So that's the second. The third one is how to see at all those requirements. The good news of writing requirements here in Rhapsody is that you can have all connected to models. But the bad news is that you don't know the requirements you don't know at all what the list of requirements for your story. Where's your story? It is disseminated along models. So what it is, from our point of view, interesting is just to again take a look at the requirements, but as if you are in a requirements management system. So now you get the RAT, the same RAT that you have, but now this RAT is going to be the RAT grid, as you also know. So now we are looking at all the requirements in a particular level in Rhapsody. These requirements can, of course, by the way, if you demand this, can be saved indoors or in PTC Integrity or in Retrieval or in Excel or whatever. So you can somehow produce this connection between the requirements that you have inside Rhapsody and the requirements that you can then put on the requirements management system with version control, baselines, and so on. Okay. What we are doing now is we are changing this requirement. Of course, we change it through RAT, and they will be changed both in the grid and both in Rhapsody. Okay, and well, we just put it here, and then you can see that it's been changed there in Rhapsody. Let me finish that one. Let me go to the next use case. In that case, we are offering the possibility to simulate requirements together with information about models from Rhapsody. And this is the case again. So let's go and run this video. In that case, I'm going to show you a little bit more complicated. I hope that you understand all that stuff. In the right side, we have a physical modeling tool. In that case, is Open Modelica, and we are modeling what could be the trajectory of a particular rocket. Okay, then it's the standard typical physics formula that we study in school. So in the right side, you have this standard modeling. You can see that we have an initial speed, an angle, and then it just creates a particular height. And then in the left side, what we have in the left side is a requirement in Rhapsody, which of course is connected with the model, because a rocket has some particular information. In that case, it's the alpha information. So we are having the angle of this particular model is stored inside the Rhapsody class or block. And what I'm showing you now is that we have in this approach of simulating requirements from Rhapsody, so we have the choice to configure this simulation against an FMU. So in the right side, we are using this physical model, and then we produce an FMU, and this FMU is connected with the requirement and the model, and configured to be populated using information from the requirement and information from the model. So these four elements are the parameters that are necessary to be included to run the simulation. And what we are going to do now is we are changing this information in Rhapsody. So we are putting the 30 inside the alpha in Rhapsody, and now we connect, as you're going to see now in a second, we connect this information with the FMU input. So what is meaning is simply that the alpha angle is going to be extracted from the rocket alpha property, while the height would be connected would be extracted from the requirement in Rhapsody. So now what we are doing is running this FMU, and the run of FMU, of course, would now this is information we are giving you in this video for showing you that we are getting the 230 out of that, and what we get the result is that the red is a red color inside the requirement in Rhapsody, because as you can imagine, if we just put the 30 degrees in the simulation tool, you can see that we don't get the 200 meters height. So the rocket gets below. So what is going to be done now is, if we put it now back to 45 in Rhapsody, changing the value of the property in the class, what it must happen is that then we have to have a green requirement. So we put this 45, and then what we have to do is to run again the simulation of the requirement against this FMU, and that must mean that then it would be green. And of course, the last part of this demo, I'm just going a little bit beyond the video, but the last part of this demo would be also to change the there is the 45 and 200. And would be also to change the information on the requirement to see that if we change the information in the requirement, we can also get bad news. For example, if we put 2,000 meters, if we change that the rocket shall reach a height of 2,000 meters, then of course the simulation is going to tell us that this is completely impossible to be fulfilled by the requirement because of the physical model. So when we connect again the requirement and the model with the FMU, we will get the information connected to the FMU through the parameters 45 degrees, 2,000 meters, and of course the requirement is failing. Okay, let me stop here. Let's go a little bit towards generating models. So the notion is again the same. We have to define particular patterns for understanding. In that case, we are going to generate logical models in SysML. So we have to have particular patterns to understand requirements that describe information that is necessary or that's interesting to be located in a model. So what we are going to do is, in that case, we are going to connect a requirement specification indoors. I'm going to move a little bit this video because it's 15 minutes, and I wouldn't like to. Let me see. I wouldn't like to spend so much time, so I'm going to bring it up here. So this is doors loaded, and we are showing you here in color several interesting requirements that you can imagine that could be transferred and translated into information that could appear in a model. In that case, for example, this information is structural. So you can see that the fan shall have 3 fan blades, and then there are other information in regards to properties of power consumption in that case. And we have some other, let me go a little bit farther as well. Okay, here, and you have properties of composition, and then you have transitions. So we have made a kind of bunch of different requirements describing a lot of things all together for this demonstration. And the purpose of this video now is to see that when we define a model inside Rhapsody, we would be able to generate quite a lot of things, not only compositions, but also state diagrams, and we can generate hierarchies and all this information that usually is structural or dynamic inside the different SysML models. So once we are still showing you in the video the type of the transitions that you can see, the interesting thing, of course, now is to start bringing these models or creating these models on an existing rational Rhapsody file. So we are opening, I think, this aircraft one. And the selection of the type of diagram that we want to create as master would imply some choices in the configuration, but we go to RUT again, so you can see that the plugin menu is there, and the only thing we have to do is now to configure several things, like the typology of the diagrams to create, and in some cases you have other possibilities to filter or to define the name of the model to be created or the diagrams and so on. Okay, so let's go into what the video is showing you is the different options. You have seen some of them in the previous videos. So let me see if we can just get a little bit quicker. There we are. So now what we are doing is opening the RUT. and we select, of course, from the RAT the requirements existing in the DORS module. And these 80 requirements are being loaded inside the grid of the RAT. And you can start seeing there that, well, they're putting in one on the other. And you can see there that their requirements are, well, it's stupidity, but they are the same, one in one or the other. And once, let me see, if I advance a little bit more. Okay, there we are. So just generate, give the name of the model, define the topology of the diagram to be created, and once this is done, the model is generated. It's showing you the possibility to create different types of models. And I think the block diagram is going to be created. So when this selection is done, the model is produced, populated, filled, and drawn. And this, you can start seeing that one here. And this aircraft model is the one that is produced. And if we just open it, we are going to, the rest of the video is going to show you the different mappings between the model produced and the requirements existed. Okay, so for example, we have a lot of compositional elements with several properties there. The famous fan that we were saying that has several fan blades appear there with the different power consumption limits, if you remember, from the different requirements existing there. And well, this information is going to be contrasted now with the different requirements inside Rhapsody. So I'm going to go a little bit more quicker just to show you. Let me see. Well, you get a lot of information here. So in this information is properties being populated inside the fuel tank, and I think in the next diagram you will see how we have just extracted also several information around state diagrams with the requirements that were describing transitions. I'm going to leave it here to be able to finish on time. The next part is going to be to generate text. It's a couple of minutes, 5 minutes more. So we are going to generate requirements, test cases, and so on. And the approach is, instead of selecting all these bunch of possibilities, we are going to do it from Excel to Excel. Okay. So let's go and see how can we generate test cases out of requirements. What you get here is the System Interoperability Manager, and what you're having here is a transformation. So each of these three elements is a transformation, and in order to do transformations, you have to select the source. In that case, are the requirements. These are the requirements, and then you have to select the target. Where are you going to put the results? And in the case of the second data source, would be the test case Excel file. Of course, you can imagine that all the connectivity possibilities that exist in reuse tools, to DORS, Rhapsody, or Magic Draw, PTC, Excel, and so on, are available for whatever all these possible transformations. So in that case, what we are going to do is we are going to generate test cases from their requirements. In particular, we are going to generate one test case, the test cases for one requirement, the first one. We are going to select only the first requirement, and we are going to generate, we are creating the traceability already automatically between this requirement and the test cases. And what I'm showing you here are the test cases generated by the transformation defined. So if you remember a little bit about the requirements, so this is producing 4 different test cases, defining the different scenarios for interesting organization of variables. So where the test cases must be concentrated. In one that the fun is off, two in the limits, and one that the fun is on. Okay, so interesting thing that you can see is that you have some arrows there. That means that these test cases has been traced against the requirement. So now you have these traceability links. This is the traceability manager inside the system interoperability manager, and it just simply have made the traces of it. Let's go into translation issues. So translation issues are nice because in some cases we have heard of our customers that they were interested in producing local language requirements. Some cases they can come requirements in German, for example, or in English, and the level of English or German is perhaps not so good at the receivers, and what they would like is just simply to translate it. So what we are going to do here is to create a translation with the corresponding traceability, of course, between the test cases we produced before in the same document with the test cases produced in French. So in that case, we have just made a transformation between the test cases in English and the test cases in French. Okay, it's a couple of minutes, and let me just simply show you one stupid experiment that we have done, because these platforms are completely configurable, and what we have done just for fun is to produce an anonymization of requirements. So what we are going to show you now is transformation, custom created transformation, where you get all those requirements and we just simply anonymize them by hiding the different nouns inside the requirements. Okay, anonymize requirements, select the source, which is the requirement specification, and the target is the same. And when you run that, you will see that in the same specification, we have produced the requirement just simply hiding the terms. We show it there. You can see there that they have been produced. Okay, so I have several information with no demos that I didn't want to show you later on. So my conclusions are requirements engineering can be improved by merging it with model-based systems engineering and vice versa. We think that requirements engineering can be really assisted if requirements are automatically managed and formalized in the way we do with these graphs. It is possible to generate activities and trace them among different processes, requirements to models, physical models, risk, and so on. And of course, model-based requirements engineering in our approach is a kernel for better requirements engineering. So, Jose, I'm done. I don't know if there are some questions.
Thank you, Juan, for this wonderful presentation. We have one question here already. So the question is, you presented a demo with requirements and models in Rhapsody. What if I use doors and Rhapsody instead of everything together in Rhapsody?
So let me see. If the question is meaning that if it is possible to create or edit requirements in Rhapsody that exist in doors, yes, the answer is yes, you can do that. But this, if you see a little bit how this inside Rhapsody is working, it is generating, well, editing or generating requirements that physically exist in Rhapsody. So the solution, if you have requirements in Rhapsody and doors, is that you will have both of them in both tools. So what it's necessary to do from our side is to link them, to trace them, but the requirements would be in both sides.
Okay, thank you, Juan.
Yep.
Second question is there a difference between a requirement written the way you did it and the native Rhapsody requirement type?
No, there's no difference. What we create is a requirement a requirement of the requirement type inside Rhapsody.
Mm-hmm. Thank you, Juan.
Yeah. More
questions, please. Okay, the third question is, you have shown the creation of test cases and its translation. Then you said that a traceability link is generated. Where is it stored?
Okay, yeah, good question. Let me put it here. What you see in this screen is the System Interoperability Manager. It's a tool that I told you in the beginning that is one of the new tools coming in the version 18th of all the reuse company tools. And this tool has the following elements, if you can see there. It has a reasoning manager for doing reasoning, a kind of machine learning approach. Then you have the Traceability Manager, T+. It's a manager that just simply allows traceability between all the different connectors that we provide in the Interoperability Manager. And the Transformation Manager, the one that we have seen in this webinar. So the answer to your question is, we produce the transformation between the different source tools. For example, we can create models from doors into Rhapsody, or we can generate test cases in Excel, or generate requirements in Retrieval. And the traceability link, it's stored inside our databases in the Traceability Manager, in the T+, considering also that it manages the change management as well. So that means that if you change the requirement, or if you change the model, or if you change the test case, then the traceability link is suspicious or suspect. And then you have to manage, of course, the traceability to see if it is still valid or not. So that means that, to answer your question properly, the traceability is stored in the universal traceability manager that is existing out of the box on the System Interoperability Manager.
Okay, thank you. One more question. This is related to the second of the questions. So remember that the second question was whether or not there was a difference between requirements written in this way or native requirements in Rhapsody. Now the question is, what about configuration management for these requirements?
Yes. There we don't provide configuration management for the requirements written inside Rhapsody. We will provide a configuration management in the next version, 18.2. So in 18.2, we will provide configuration management to everything, to all the different work products. If you connect to a particular work product, we will provide at our side configuration management. How tricky is that? It's a lot of tricky. I mean, it's quite tricky. The reason is because configuration management at our side would mean only that the formal representation of this element has changed. So if, for example, suppose Rhapsody. So if Rhapsody provides configuration management for this requirement, which I'm not sure, but I don't think it does, then of course you have this available for you. If you don't have it and want to have configuration management, version control, baselines, and so on, we would produce it. But the problem is that for us, we would never store the element itself. We will store the graph, the graph that I showed you before. We will store the graph, and we would give you configuration management of the text of the graph, text of the requirement, together with the formal representation of the graph. I don't know if I have answered you.
Okay, let's see. I will change the order of a couple of questions just because this one is pretty much linked to the previous one. Is it possible to manage variants of requirements? So, for example, depending on product customization.
No, this tool, the System Interoperability Manager, is not a product line manager. So we don't provide variants of the different requirements, although it is something that can be produced. So it can be customized. We don't have it out of the box, but if you are interested, you see the custom ball here, and this custom ball is capable of connecting the patterns with the requirement itself and produce variability or variants there. Let me tell you that we are working on a product line project here in Europe, a huge one. It's called Revamp 2. And the intention of this project, I don't know if it would be in the last version of this year or in the version of next year. But what we are doing in this project is generate automatically out of requirements, existing requirements, generate the product lines and the variants, the product lines and the variants automatically out of the requirements. So the process in I should say some months, or probably at most in version 19th, we will have one more button in this manager, in SIM, where you would be able to connect to doors or to Rhapsody or to text or Rekiv and generate automatically product lines, and you can store them in pure variants or in ourselves if you want.
Okay, a couple of questions more. If the version of Rhapsody is updated, how long does it take to update the new features you added to it in the latest Rhapsody version?
Wow, this is a very good question. In principle, in theory and in principle, and I don't dare to be so proud, but in theory and in principle, we don't have to do that, because we can configure every time a new version of Rhapsody is coming, we can simply configure the connection with Rhapsody. So that means that if for example, there are some customers that are using really complex profiles in Rhapsody. And what we are doing inside this connector for Rhapsody is just that the user can configure the different elements that exist inside Rhapsody. So in regards to stereotypes and profiles, there's no limitation. And of course, if the question comes from new properties coming from Rhapsody, for example, I don't know, let me imagine a new one. Rhapsody is just providing automatic generation of physical models out of architectural logical models. Then of course, we from our interoperability platform, we should have to update our APIs against Rhapsody to do that. But if IBM people, and I hope that Andy is here, I don't know if he's here, but if IBM people are interested and support and maintain the OSLC-KM connector that I told you before, if an agreement between, no agreement, if IBM simply decides to get into the standard of OSLC-KM and they update the OSLC-KM together with the new version, then nothing is necessary to be done from our side. Nothing. We just simply connect to the new element and get all the new features through OSLC-KM.
Okay, and the last one for now is in the current RQA tool, you can connect to different requirements tools. But now all your examples are on Rhapsody. Can you connect to other modeling tools?
Yes, we can connect to, in principle, well, we can connect natively to Magic Draw, Papyrus, and I think, I don't remember now because I don't know all the connectors, but I think that those are those modeling tools that we support. But the connectors, the connecting window is based on transformations, XML transformations. So that means that in principle, again, and it must be tested, of course, if you have a particular one, you're proprietary or something like that. But in principle, if you provide an XML file of your information, we simply connect to it. And we connect and configure this connector that and you see all the information inside your XML file as if you have seen the information in Rhapsody. But this must be tested. I don't want to say a proper yes before we see. But somehow important for me to answer you is that you don't have to wait for a new version of our tools. We have generic connectors. That means that you can configure your own connection. So if we don't provide a native connector, you can create a transformation of the XML file if you are having XML information. Today is more or less a standard, and you would be able to connect to this specific tool with no need of an update from our side.
Okay, thank you. One more. Is there a proof of completeness of test cases generated, meaning coverage demonstration?
that's good point. No, we don't have any proof of completeness, but if it is necessary, it can be generated on the ontology. So if I understand properly, perhaps I'm not understanding the question, but let me put an example. If you can just correct me if I'm wrong. If you, for example, for testing a system controller, where the activation element is a transition based on time, if you want to create 4 or 5 or 10 different scenarios, one at the tolerance level, one by far beyond, one on the tolerance level by the other side, and one before, then you can simply define these transformations on the ontology, and what the tool would do would be to generate the test cases exactly those that you predefine in advance. So if I understand properly, there's no proof of completeness, but it must be automatically done because you are the one that say the information that must be produced. So there's no magic here. You predefine in advance the meta model of the test cases to be generated. And what we do is we instantiate this meta model based on the different requirements. So if you have a meta model for managing temperature in intervals of 0.2 degrees, whatever requirement describing operational information about temperature and activation of elements would produce the same 4, 10, 20 test cases that you predefined in advance. I don't know if I answered your question. More questions, Jose?
Yeah, there are no more questions in the chatting box. So that's all from now. Thank you for attending this webinar. So Juan, thank you very much for your presentation. Do you have anything else to say?
Yeah, thank you very much, and I hope that you enjoy it. Thank you, Jose.
Thank you. See you soon.
Bye.
Bye.